a diagram given to you, and you need to do this. Construct the state transition table of the machine. Second one, find the partition of the state set corresponding to a machine congruence, meaning that you do the partition like just now I show you. Then the part C is construct the state transition table of the quotient machine and draw the diagram of the quotient machine, meaning that you need to do the table like this. This table. Okay, this table is the state transition table for the quotient machine. Then draw the diagram for the quotient machine. You refer to this table. So you must construct this table first. After you divide from the table here. Okay? Then the last one is tabulate the word transition function F000. This is the one that we have done last week. Okay? Now we do the first table here, the state transition table of the M machine. Now we will just look at the graph and do the table from one step to another. So you have A, B, C, D, E, and F. Just right here. Later I will erase. So these are all the sets that you have. 0 and 1 are the input set. So A after input 0 is A. A go to AF. B will go to BD. C go to EC. D go to FD. E, this is E, yeah? E go where? EF. And F go to FF. Right? All of you know how to see, right? Just follow this diagram only. Then the question here is, this is the first part, state transition table of the given machine. Second part, do what? Partition of the state set to a machine congruence as few classes as possible. Okay? So we do like just now. We need to divide the classes until we can simplify it, become a machine congruence. Which one we can group them together now? Which one can be in the same class? DE, right? Okay. I erase this, have you done? Done. I write here because I want to refer to the diagram. So A, B, C, and F will be in the one class, and D and E will be in one class. Then we just fill in on it. A is AF, B is BD, C we have EC. You can refer to the table just now because I already erased. You can refer to yours. FF, D we have FD, and E we have EF. So this is the two classes that you have after dividing the acceptance stats to one class and the rest of the non-acceptance stat to one class. Okay? Then after that, input 0 and 1, you see here, A, B, E, and F. Are these four in the same class? No, right? Which one not in the same class? So we need to take out this one. So in the next table, we will have A, B, F, C. This one, F and E, is it in the same class? No, also, right? So we need to divide this also. Okay? So now you take out the C, divide the D and E, it becomes like this. So we have AF, BD, FF, BC, FD, and EF. Now we have 4 classes here. Check again whether all these are in one of the class here or not. All in the same class? Are they in the same class? Which one not in the same class? Okay, yeah. This one, right? ABF, no problem. FDF have problem because F and D are at the different class. F is here, D is here. So these 3 cannot be together. Which one need to take out? B, yes. So you need to take out these because the D is at the different class. Take out the B, put the AF together, B, C, D, and E. Okay, then fill in again. AF, FF, BD, BC, FD, EF. Now check again. You have 1, 2, 3, 4, 5. 5 classes. All in the same class or not? Actually, the individual one you don't need to check already, right? Only check the one that is more than 1. So AF, same class? FF? Can we stop now? Not stop the class, stop the dividing. So this one, how many classes we have? 1, 2, 3, 4, 5. 5 classes, meaning that we already get the machine congruence. So this is your part B. Part C, we will do follow this table. Okay, part C, follow this one. So we have 5 classes, right? The first class is this one. We use A to represent this class. A. A. This one B, C, D, E, no choice. Only one only. So we just follow the name. B, C, D, E. Remember the bracket. So fill in this one, A and what? A and A. B is B and D. C, E and C. should we put A or F? Everyone know why I put A? Who don't know, raise your hand. Sure got someone don't know, right? Am I correct? Anyone don't know why this one I put A instead of F? See, when I go to tutorial class, still have someone will ask. Why I put A here? D after you put 0 is F or A? Here. Look at the original table. It is F or A. This table. D after input 0 is F or A. F or A. In this table, D after input 0 is F or A. Hey class, are you here? So the D after input 0, what do you see here? F, right? When you go to the quotient machine, can you write F? Can you write F? Can you write F? Cannot. What should you do? You should follow the class that you use here, right? If you use A for the first class, then you put A. Okay? Follow the class name you use. If you put F, then you put F, no problem. Okay? You must follow the name that you use for the first class. Normally we take the first one. So every time you will remember, oh, the first one is the class name. Okay? So we get A, D here, and E also the same. What do we get? E and A. Yes. So this is the part that asks you to get the state transition table of the quotient machine, and also you need to draw the diagram. Can you draw? Refer to this table. Can, right? So you draw yourself. This question. Construct the diagram and then draw the diagram of M over R. So the diagram of M over R, you refer to this table and draw. I believe all know how to draw already, right? Okay. Last one is tabulate the word transition function of F000 for the original machine M. How do we want to tabulate this? Still remember? F000. A, B, C, D, E, and F. Give me the answer. A is B, B, C, E, D, F, E, F, F. Okay, just look at the string of 000 from the stack that you are in. Which stack you are in now? Just follow the string 000. Okay? You can go back and draw the diagram. I don't know how many will draw. So we go to another part where we will look at another type of finite state machine. Now, previously I told you that every stack there will have one input 0, one input 1. go to either the same stack or they will go to another stack, right? It depends on the input given. If you have 2 inputs, then every stack will have 2 inputs. Now, this one we call it as a finite stack machine. But not every time the stacks will only have 2 inputs. Sometimes, maybe some of the stacks they will have input 0 go to A, input 0 go to B, or they don't have input 0 go anywhere. Possible also, right? So in that case, where the input for one stack is not only go to one different stack or the same stack, then that machine we will call it as non-deterministic finite stack machine. Meaning that the input here, it is not compulsory only 1 for A, not only 1 0 for A, not only 1 1 for A. It can be 2 0 for A, it can be none, it can be 2 1 for A, it can be none, and so on. Okay? So the number of input for each stack is not compulsory only have 2. That is under non-deterministic finite stack machine. So look at this here, the components are still the same, where we have the stack set, input set, stack transition function, starting stack, and the acceptance stack. The 5 components are still the same. So we will look at how to do this. Let's say you have this table, and we start with the easiest one, which is draw the stack transition diagram. Follow the stack here after input 0 and 1. Where are all the stacks go? Draw one by one. Okay? I believe you know how to draw. S0, S1, S2, S3. Which one are the acceptance stack? So, you see this table, S0 after input 0 go to S0 and S1, isn't it? So you see here, the 2 input 0 go to one S0, another one go to S1. 2. Just now, we don't have this case, right? So only for non-deterministic, it will happen like this. 0, input 0 can go to 2 different stacks. Then for S0, input 1 go to S3. S1, after input 0 go to S0. And after input 1, S1 will go to S1 and S3. So S1 has 2 input 1. For S2, input 0, nothing here. So S2 don't have input 0. Then input 1, S2 will go to S0. This is 1. Or go back is input 1 also. S3, input 0. Zero. One. 2. 3 input 0 for S3. Go to S0, S1, and S2. All these 3 are input 0. Go to 3 different stacks. And input 1, S3 will go to S1 also. So instead of you draw another line, you can combine this one with input 1. No need to draw the different line if they go to the same destination. Okay, just join the input together. So this is the state transition diagram for the non-deterministic finite state machine. Remember the acceptance state now, whatever they give you, either is in the set T or they will tell you that the acceptance state is which state, then you draw the double circle. Okay? Done, huh? For this one, they say find the state transition table. Opposite lah. Just now is the table given, you draw the diagram. Now is the diagram given, you construct the table. You can do, huh? Can, right? S0, S1, S2, input A and B. So input A for S0 go to S1. Input B don't have. S1 input A don't have. S1 input B go to S0 and S2. And S2 only have input B go to S2. If there is nothing here, you can put empty set. So now we want to know what are the language that will be recognized by this non-deterministic finite state machine. So it is the same also where you need to find the string that it will start from S0 starting state until the acceptance state. So sometimes because of there are many different input for each state, so they can be a very complicated non-deterministic finite state machine. So you will be, you need to think more how to write the LM. Now, refer back to the example 10. How do we want to see here? Write some of the strings which are recognized by the machine and determine whether the input string ABAB is in the LM. What we want to do now is, example 10 is this one. Can you give me some of the string that will be recognized by the machine? What are the strings we can have? Easiest one is AB, right? I write here. you write below. AB are the string that we can have for this example because you will go to the acceptance tag. What else? AB, 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 AB. Can AB be accepted by the machine? Can or cannot? Can AB be accepted by the machine? Can or cannot? Can and cannot. I should use and or I should use or? And or. Which word I should use? AB, how? AB can be accepted. AB can be accepted or not? AB at S0, right?
Yes.
AB accepted. AB S2. AB S0. Then can and cannot. Okay. So for the string that we have now, you have AB. It depends on your string whether you go by S0 or you go to S2. Then others you can have ABB, you can have AB, BB, and so on, right? Because the B here is the loop. So you can have many strings. Now, they ask you to whether the input string AB is in the language of the machine, and then write the language of the machine, LM. Okay, now for this one, I already show you the string that are recognized by the machine, and you also know already, you can write many, AB, you can write ABB, you can write ABB, and so on, Then, AB is in the language accepted by the machine if we go to the S2, right? So the language of the machine, how to write? The LM. In general form, how should we write the LM? Refer to the diagram. FB. How to write the LM? Like your LG. How you write the LG from the master diagram? This one is how you write the LM from the step transition diagram. AB S3. Where to put the S3? Yeah. This AB is referring to this one. You refer to this. How? Any idea? Can we repeat this many times or not? Can. So means can or cannot? Can. Every, right? You can keep on repeating, isn't it? Okay. So how to write? Put the bracket, parentheses here, then asterisk, isn't it? Then? Then after that? B first. You repeat the every. You must stop at S0, right? Then, if I don't want to repeat anymore, how? AB. Okay. I need another AB, right? Then? B as correct lah. B, you stop at S2, isn't it? What happened at S2? Loop again lah. You can loop, isn't it? Keep on looping there. So how to write keep on looping there? Do I need to write B asterisk again, or I can straight away write asterisk B here? Can I straight away write like this? So I need to write AB asterisk, AB, B asterisk. Agree? Why I cannot write like this? Why I cannot write like this? Yes, because this is a loop, isn't it? If the asterisk is 0, then I only have A. But for this diagram, the shortest string we have must be A and B. So you must have this in your string. No loop for that. So you must have one AB at least to go to the acceptance step. Okay? So this loop is at the back. You want to go to the loop or not? It's up to you. So the LM now is conclusion. Right here. AB asterisk. ABB asterisk. Right? You get this. Can we continue? We have how many more? This one is convert the deterministic, meaning that you just now you already have the non-deterministic, right? How to convert this to deterministic? Meaning that how do you want to convert from one step which has more than one input to one step which only have input A and B? Now, this question here, as in the example 10, we can try to convert this one. Okay, I write this part, I write here. So that is the last one. Very easy only, this one. I stop after this. So now we start with S0. Now, when you want to convert to the deterministic from non-deterministic, we will put it in a bracket like this, curly bracket, to show that it is a class. Then, here is A and B. Okay. S0 after input A, S1. S1. Okay, B. And B side. Then since you have S1 here, right? Listen carefully. Here you have S1. So next one you go to S1. Next step you go to S1. S1, what do you get? Empty set and S0, S2, right? Next one, what should we write? Zero, 2. 0 and 2. Here you have 0, 2. So, in the next step, you write 0, 2. Follow whatever you have after the input A and B. Don't follow don't follow this side. Don't follow this one, huh? Both what? A and B also have. Then you write one by one. If A go to S1, S2, then next one you can write S2. Then the next one you write 0 and 2. Okay? Both also need to include. So now 0, 2. 0, 2 means you need to combine this one, the 0 and 2. 0 and 2. After you combine the 0 and 2, what do you get? S1 only, right? This one, 0 and 2. So you get S2 lah. Okay? From this table. Then now you have S2. Okay, so next one we go to S2. S2 you have NT set and S2. Any more?